In this video, we will look at some additional computations associated with the normal distribution. First example we'll work through, again, SAT scores, normal, mean 500, standard deviation 100. If you aspire to score at the 95th percentile, i.e. you beat 95% of the population, have 5% scoring higher than you. If you're going to be at the 95th percentile, what score do you need? Step 1, always draw a picture. Here's our picture. We're wanting this area to be 95% of the curve, and we're looking for the cutoff score that gives us 95% below it. Notice what we've done in this problem. Our previous problems, we knew the cutoff score, and we're looking for a probability. We said, given an SAT score of 650, what percentage score that much or less? Now we flipped it around. We know the probability and want the cutoff score. 95%? What's the boundary, the cutoff, that gives us that much of the curve? In Excel, these are the inverse normal functions. We can either, once again, work with the raw data scores, give it the mean, standard deviation, and probability, or we can work with standardized scores, the z-scores, and use the standardized form of the function. In this example, our probability was 95th percentile, mean of 500, standard deviation of 100. We can find the inverse, 95%, 500, 100. Again, you can type this in directly, or you can use the function wizard to build it for you. Either way, in a case, we get a 664. And you need to beat this score to be in the top 5%. Alternately, you could have said standardized function of 95%, 1.645. In other words, we've got to be 1.645 standard deviations above average to be in the top 5%. 1.645 standard deviations, 100 points is one standard deviation, so we're this many points above average. Above average puts us at 664.5. Again, either way is fine. Let's do a second example. Normal distribution, mean of 5'9", standard deviation 4 inches. If you aspire to be among the tallest 1/3 of the population, how tall do you need to be? Take a minute, work this one out. Again, pause the video, work through the problem, then unpause the video and check your solution. I know you began by drawing a picture. The tallest 1/3 of the population is up in here, above this cutoff that we're trying to find. But we do not look the probability of 1/3 up in Excel. Why not? Because Excel is built in terms of this area under the curve, from a certain point on down. And so we need to look up this area, which is 2/3 of the curve. We can use the regular inverse function, 2/3 of the curve, mean of 69 inches, standard deviation of 4, gives us 70.7 inches. Or we can use the standardized version, which will tell us for 2/3 of the curve, we need 0.431 standard deviations. 0.431 standard deviations, 4 inches is one standard deviation. Add that on to our mean, either way, 70.7 inches. If you're that tall or taller, you're among the top 1/3 of the male population. In summary, we've noted two sorts of normal distribution problems, each of which has a pair of functions associated with it. If we know the cutoff score and want a probability, we will use the dist versions of the functions, either regular or standardized. If we know the probability and are looking for the associated cutoff score, we will use the inverse versions of the functions, either regular or standardized.